Hello guys, this is Prime Concept. In this video, I want to solve the problem on the board, which is still a problem that concerns wave. So we have wave equation. So we want to use wave equation that was explained in our previous video to solve some problems. So we can learn how this is actually applied. Now let's look at the problem very quickly. It says if a wave is represented by the expression this. So the wave expression is y equals a sine into 1000 pi t minus pi x over 17. And remember, the displacement y is measured in centimeter. So it means that any displacement we'll be dealing with in this particular equation is going to be measured in the units of centimeter. So that is very important. And we said where t is in seconds and y is the displacement. And they want us to find the wavelength. So that's the first thing we want to find. And whenever you face this kind of problems, so you are expected to solve for most of these parameters by comparing the equation you are given to the standard equation of a plane progressive wave. Now we know that the equation of a plane progressive wave is y equals a sine of omega t minus 2 pi over lambda x. This is the standard equation we know. So we can compare these two equations and find the parameters we're supposed to determine, right? If you are watching this video at this point and you are yet to subscribe, please use this opportunity to hit the subscribe button so you can show your love and support for my channel. Now, by comparing this, you notice that we have x at this point, we also have x at this point, and this is the point where we have wavelength, and that is where we have x, because the first question says find wavelength. So we can compare these two sides that have x, and then this one has wavelength, so that I can say that 2 pi over lambda x, which is this part, should be the same as what now? Pi over 17x, right? Now if you watch, there are certain parameters there that can fizzle out. This pi can fizzle pi, right? Yes. X can fizzle x, so that I'll be left with what? 2 over lambda, which is equal to what now? 1 over 17. So if I cross multiply, I would have 1 times lambda is going to give me lambda equals 2 times 17, which is actually equal to what? 34. And the unit is what? Centimeter. So I've been able to find our lambda. Now the next part of the question says we should find velocity. So, and we know that velocity can be gotten, v is f lambda, right? Yes. Now let's see. For us to get our velocity, we might need to get a frequency, right? So let's start by getting a frequency. So if I compare this side, you would see that omega t, which is what you have here, is equal to what? Is equal to 1000 pi t, is equal to what you have here. So, but we know what omega is, right? Yes, we know that omega is 2 pi f, then times this time t, which is equal to 1000 pi times t. So some certain things can cancel out. So time would fizzle time, pi would fizzle pi. So that if I make frequency the subject, I would have that f frequency is going to be 1000 divided by what now? By 2. So this would give me 500 hertz, right? So I've been able to find the frequency, which is supposed to be the third question here, but that notwithstanding, with that I can get my velocity. We know that velocity v is f lambda. So, and I know f as 500 times my lambda. My lambda is what now? 34. So that when I multiply these two things, 500 times 34, I would have 17000. So this is my velocity. What is the unit of the velocity going to be? You are very correct. Since my wavelength is in centimeter, it means that my velocity is going to be centimeter per second, not meter per second. If I want this to be in meter per second, I'm simply going to divide this by 100 so that I can have that V is going to be 170 meter per second. So it's either you say 17,000 centimeter per second or you say 170 meter per second. So I believe this concept at this point is clear to you. Thanks for watching. Do well to subscribe and like, share with your friends so that they can also benefit. Thanks. Prime Concepts.